Hello, and welcome back to another Ian's Guides. Today we're going to be learning about finding eigenvalues. Now, a good place to start would be, what are eigenvalues? So we can say, let's say we have a matrix A, and this matrix will be a transformation matrix. So we got transformation matrix. And now let's say we have a vector that we're multiplying with this, and we'll call this our eigenvector. Now this will be equivalent to our eigenvalue times our eigenvector. So we'll call this our eigenvalue, denoted by lambda, and we have our eigenvector. Now that is the same eigenvector that we actually put into the equation initially. So essentially what we're doing is we are taking a transformation matrix, we're multiplying that by an eigenvector, and then we're actually getting out an eigenvalue times that eigenvector, where essentially the eigenvalue is some scaled factor of that eigenvector. So for example, the eigenvalue could be 1, it could be 2, 5, it could even be complex as well. So one thing that we can do is we can simplify this slightly by saying, if we have AV, and we subtract that right-hand side, so we can do minus lambda v, and that's going to be equal to our zero vector. But we can actually simplify this ever so slightly more. So we can say, if we have AV minus lambda I, where I is our identity matrix, because we can essentially say this in this case, because if we multiply any number by 1, we're going to get that same number back out. Where in this case, with the identity matrix, if we essentially multiply any scalar or any vector with that, we essentially get the same value back out. So we can write it as so, and then we can actually pull out our eigenvector. So then we'll be left with a minus lambda times I, all times our eigenvector is going to be equal to the zero matrix, or zero vector, essentially. Now, as we can see by our little note down here, we do not want our eigenvector to be 0. Otherwise, this will always be true, and then we don't really get any information out of that. So what we can do instead is we can essentially think about the determinant, right? So if we have the product of some, matrix vector, essentially the only way that that can equal 0, or one of the only ways that that can equal 0, is if we were to, let's say, squish it down to a lower dimension. Now, essentially, it's a little bit out there, but pretty much that would be quantified as the determinant of a minus lambda I. Since it's the 0 determinant, we'll essentially set that equal to 0. Now, this is pretty much the main equation that we need for finding our eigenvalues. So we're pretty much halfway there. Now all we need is to do a little bit of practice. So let's say we have a 2 by 2 matrix, right? So we have the matrix A, and it's denoted by 5, 3, 0, 2. So the next step that we can do is by using what we have above, the determinant of A minus lambda times the identity matrix is equal to 0. So we can start writing that out, right? So we'll have the determinant of A minus lambda I, which we can also write this as determinant of our matrix here. So we'll have 5, 3, 0, 2. It will subtract that by lambda times our identity matrix. And in this case, we're making a 2 by 2 identity matrix because A is 2 by 2, and we want to make sure they're dimensionally the same. So then from here, what we'll get is we'll be essentially taking the determinant of 5 minus lambda, 3, and then 0, 2 minus lambda. And then from here, do a little color coding. We can see that we'll have 5 minus lambda times 2 minus lambda, and then we will subtract by our 3 times 0. But in this case, 3 times 0 will just give us 0, so we can ignore that part. And now that leaves us with 5 minus lambda times 2 minus lambda is equal to 0. And now one thing I want to note real quick is this is actually called our characteristic equation. Now, essentially, our characteristic equation is pretty much the result of our determinant. And then this will actually tell us what our eigenvalues are. So here we can see off the bat that lambda 1 is equal to 5 and lambda 2 is equal to 2. Now, the cool thing about this is this tells us with our two eigenvectors that we can see, hint, hint, for the next video, that when we multiply those two eigenvectors with our matrix A, we're essentially going to get those same eigenvectors back out, except they're going to have a factor of 5 as well as a factor of 2. So the next video, we're essentially going to be talking about how to find our eigenvectors now that we know how to find our eigenvalues. See you next time.